Hello everyone, welcome to our channel. Today we are going to solve one numerical problem for the Pelton turbine. We are going to solve the Pelton turbine design. The question is design Pelton wheel turbine for a hydropower plant which have a net head of 312.5 meter and discharge of 5 meter cube per second. Take the efficiency of the turbine is equals to 85%. Now let's start with solution. And the given is discharge equals to 5 meter cube per second. Efficiency equals 85% and net head H equals 312.5 meter. Now for Pelton turbine, velocity of jet V equals CV root over 2GH, where CV equals coefficient of velocity. Velocity, let's consider it as CB equals 0.98. Then V equals CB is 0.98 root over the value of G is 9.81 and the head is given as 312.5 meter. On solving this, the value will be 77.83. Now using the discharge formula, Q equals area into velocity, where area is equals Q by V, that is the discharge is given as 5 and the velocity is calculated as 77.83 equals 0.064 meter square is the area. Now the diameter of jet can be calculated as D equals 4A is divided by pi, where 4 the value of A is 0.064 is divided by 3.14, and its solving will get 0.285 meter. Again, the diameter of runner can be taken as capital D is divided by D equals 15, that is D equals 15 times of D. This can be written as 15 into the value of small d is 0.285, or D equals 4.275 meter. Now number of bucket runner Z equals 15 plus capital D is divided by twice of D. Now placing the value equals 15 plus the value of capital D 4.275 is divided by 2 into 0.285 is the value of small d. On solving this, we'll get 22.5, which is nearly equals to 23 numbers. Again, the bucket spacing equals pi d is divided by z equals pi times of d is 4.275 is divided by the value of z is 23 equals 0.583 meter is nearly equals to 58 meter is the required dimension for the bucket spacing. Now let's calculate the speed of runner. That is N equal 60 P bar by D, where P bar equals tangential speed pi d pi d. Speed, which can be calculated as b bar equals phi 2 gh whole ruled, where phi equals speed ratio. That varies from 0.43 to 0.48. Here we consider it as, let's phi is equal to 0.46. Now placing the value of phi in this, where b bar equals 0.46 root over 2 into 9.81 into h means 312.5. On solving this, the value of tangential velocity is 36.02 meter per second. Now using the value of tangential velocity, tangential speed on n equals 60 times of 36.02 is divided by pi to the value of d is already calculated, 4.275 equals 161 rpm. Now numbers of pole and p equals 120 f is divided by n equals 120 into f is the frequency of generator equals 50. Let's consider the 50, and the value of n is 161. On solving this, it will be 37.26. Let's consider it as 38 numbers. So the corrected n equals 120 f is divided by n p equals 120 into 50 is divided by 38. On solving this, the result will be 157.89, that is equals to 158 rpm. Now let's calculate the power. Power p equals efficiency g q h, where efficiency is 85%, the value of z is 9.81 into q is 5 and h is 312.5. On solving this, the power will be 13028.9 kilowatt. Now converting this power into horsepower, 13028.9 is divided by 746 equals 17465.02 horsepower. Now the corrected ns equals n root over p is divided by h 5/4, where the value of n is 158, the power in horsepower is 17465.02 is divided by h is 312.50, power 5/4. On solving this, we'll get 15.89, which is nearly equals to 16 rpm. This is the final required answer. So for this time we end up to this. We'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.